welcome to our channel. In this video, we aim at providing a step-by-step approach in establishing a non-secured and also a secured OPC UA communication between S7 PLC and an OPC UA Client application, and also between the S7 PLC and a Python script. First, we will be establishing a non-secured OPC UA communication between the PLC and free OPC UA Client application, and then we establish the OPC UA communication using our Python code. Then we will run a secured OPC UA connection between the PLC and the UA Expert application by utilizing the TA portal security options. Then we will use the Python program to establish a secured connection. An added feature in the Python code is retrieving data and then displaying the data in a table and finally storing the data in an Excel sheet. Do kindly like and subscribe so you don't miss out of our insightful tutorials. Thank you. Let's start by running the non-secured connection using the free OPC UA client and also the Python code. To start with, we will download Python and install it. Here we see Python has now been installed. Next thing we do is to install an IDE. Here we will use Pycharm. I will proceed to download the community version and then install. Now, I will create a project in TIA Portal and add the CPU. Note that you would need to have a CPU that supports OPC UA communication. As we see, this selected CPU does not support the OPC UA communication. This is because there is no OPC UA option in the properties window of this selected CPU. I will proceed to change the firmware version of the CPU to one that has the OPC UA option. Here we have the OPC UA settings available. To proceed, we will set TIA Portal as the OPC UA server by enabling Activate OPC UA Server. Here in the security option, under security policies, I will need to ensure that the no security option is enabled. This will allow me to establish the OPC communication without the security option, and when we get to the path where we want to establish a secured connection, we would need to disable this option. Next, under Runtime Licenses options, I will select a runtime license and compile. I will proceed to create the data block with variables to be shared via OPC UA. I would need to ensure that the block has the data block accessible from OPC UA option. By having this enabled, we will be able to read the block in the client application. Now I can run the simulation. I will start PLC Sim Advanced and switch the online access from PLC Sim to PLC Sim Virtual Ethernet adapter. I can check the IP address of the virtual Ethernet adapter by opening the Network and Internet settings. Here we see the IP address and the subnet mask of the adapter. Now that I have defined the IP address of the adapter, I can proceed to download into the PLC instance. Here I am, yet to enable simulation in the project, which I will proceed to do, then I can download into the PLC. First, we will connect to the free OPC UA Client application, then with the Python script, and finally with the UA Expert Client application. Here is the Pycharm environment where I will be writing the Python script for an OPC connection with the PLC. First, I will be launching the free OPC UA Client app via Pycharm to test the non-secured connection with the PLC instance. To launch the application, I have installed OPC UA Client using the PIP prompt. I will also install OPC UA. Having completed the installation, I can launch the client application by calling OPC UA Client. I need to insert the server address. I can obtain the server address in the OPC UA section of the PLC property window. Now, I can connect to the PLC, which is the OPC UA server, using this client application. And here we see the connection is established. Here's the PLC. Here I can find the global DBs in the project. Here is the global DB I had created and the variables. Here I can see the value being retrieved, and here I have the node IDs of the variables I am accessing. Now, I will proceed to change the value in the data block on data 3 and observe the change in the OPC UA Client application. Here we see the value being retrieved. I will as well change data 1 value in TI Portal. And here we have the value updated in the client application. Now that we have established the communication between the server and the client, we can proceed to write the first Python script that uses the OPC UA library to connect to an OPC UA server, read values from multiple nodes, and print them in a loop. Here, I am importing the client library, which allows us to connect to an OPC UA server. Also time, which will be used to introduce delays in the loop. The UR variable contains the OPC UA server address. The client URL object initializes a connection to the OPC UA server. Now I will declare the dictionary variable to hold the node IDs. Where NS equals 3 indicates the namespace index 3, while the S parameter indicates the string identifier for the variable. The connect method attempts to connect to the OPC UA server. If the connection fails, it will raise an exception. I have a loop that reads each variable's value from the OPC UA server continuously. Client.get_node redirects the OPC UA node object, while node.get_value reads the current value of the node. And I have the time delay to get the loop to wait 2 seconds before the next data retrieval to reduce server load. Here with the keyboard stop command, you get the message, program interrupted by user. And if any error occurs, like network issues or an invalid node, it prints an error message. And if the initial connection fails, this message, unable to connect to OPC UA server, please check URL, will be printed. Finally, client.disconnect ensures proper disconnection from the server, whether or not an error occurs. Now I will proceed to run the script. Here we see the data being retrieved every 2 seconds. By updating the value, we see that the value is being retrieved via the Python script. This demonstration had to deal with establishing a non-secured OPC UA communication. Before I proceed to carry out a secured connection, I will do a quick connection with the UA Expert Client application. Here I have added extra data blocks to read more variables. I have the UA Expert application downloaded and I will proceed to install. Now that I have it installed, I will be launching the application. At the first launch, you would need to create a client certificate, which will be used to establish a secured connection. I will once again download and run the PLC. To establish the connection with UA Expert, I will click on the plus sign to add the server. Compared to the free OPC client application, we can adequately select the security policy to be used in establishing the communication. Here we select the None and click the Connect icon. Here we see the OPC UA certificate used in the S7 PLC. We can basically consider the certificate to be trusted and continue. Now we have the connection established and we can browse the PLC data block. In the second part of this video, we will establish a secured connection and also make the Python script output the data as a data frame with timestamp. We will also figure out how to resolve certain errors when trying to establish a secure connection. We will also show how to create OPC server and client certificates in TIA Portal in order to establish a secured communication with the UA Expert application and with Python. An added feature in the Python code is retrieving data and then displaying the data in a table and finally storing the data in an Excel sheet. Link to the second part of the video that shows how to establish a secured connection can be found in the description below. Do kindly like and subscribe so you don't miss out of our insightful tutorials. Thank you.